Okay, so let's start. So, thank you for coming to this session. So today we're going to talk about Groovy on Android. So I'm really excited to do this talk. This is the first time you will ever see an application running on Android, written fully in Groovy. So I expect a lot of stuff from this talk. So thank you very much. Just before I start, how many people already develop applications for Android today? Right, quite a few. And do you like it? Okay. And if you could use Groovy, would you enjoy it better? Right. So I feel your pain because for this talk I wanted to write a real Android application just to be sure that I feel the pain of people using Java to develop Android applications. So this will be a bit of feedback about my feeling about writing applications using Java for Android. Okay. Of course, I have lost my... Right, it works. So just, yes, a few words about me. So I'm one of the Groovy committers. I'm a full-time committer to Groovy, so I am employed actually by Pivotal to develop the Groovy language. So I wrote, for example, the static compiler and type checker in Groovy 2, and I am one of the experts about AST transformations. So if you have questions, don't hesitate. So yes, a few words about Pivotal. So Pivotal is a company that brings you Groovy and Grails and a lot of more stuff around big data, distributed services, etc. So yeah, a bit of corporate. So if you use Twitter, and I hope you will during this session, please use the GroovyLang hashtag and not the Groovy one, because for Groovy you find level amps, and for GroovyLang you find Groovy. So the real Groovy is here. Groovy is an open source project, so we accept contributions, and especially in Android, you will have source code available, so if you want to contribute more, feel free to do that. So, the topic, Android. So why Android? First of all, it's using a JVM. You know that I have a Linux computer. I am one of the only speakers using Linux. I don't own a single Apple product. Maybe someday I will, never say no. So it was much easier for me to do that with Android, actually. And you know the news yesterday, we have now the Swift language, which is really close in the syntax to what you have with Groovy. So at least now you will be able to use that for iOS, maybe Groovy one day if I am forced to change. And the second question, of course, is why using Groovy? So I hope you know why you use Groovy. You do? Or it's just because your boss forced you to use it? Okay, I suppose not if you're at this conference. So why Groovy is also because, yes, applications written in Android are so Java 6, you know. I would say so Java 5. It's really awful. You have lots of XML files. You have string-based programming. You know what is string-based programming? Constants with strings. So you have intents and you have to put strings everywhere. So, whoa. But, you know, with microservices, it's a bit the same. You have to use strings everywhere because in the wire it's a string. So, okay, so we can do better with Groovy. So what are the problems of running Groovy on Android? Because I said that both Java and Groovy run on the JVM. Android uses a JVM, but the problem is that the JVM is not the same. So the bytecode is actually different. It's not the same bytecode. So when you write an Android application, the bytecode is transformed before you can run the application. It's not the same bytecode as the regular JVM. So you cannot use Groovy just because of that, because the bytecode we produce is not the same. Also, Groovy is a dynamic language, and it's capable of generating classes at runtime. And what it means is that even if we manage to produce classes directly in the DEX format, which is the class format that Android uses, we're not able to load them at runtime. So multiple problems. So actually those guys, so Marcin and Eric, yes, thank you. Marcin and Eric wrote a prototype a few years ago, and they demonstrate that at the Groovy and Grace Exchange in London, and they managed with the Discobot project to run Groovy on Android using Groovy 1.7. And wow, that was awesome, but so difficult, because at that time, Groovy was a huge jar with everything in that. No modules, nothing like that, so it was very complex to do that, and they were capable of running scripts at runtime. So they managed to do what I just told you was not possible to do. Okay, so it's possible. To do that, you have to do a bit of magic. So the Dalvik VM uses a different bytecode format, but it's a bit nastier than that, because even if you produce the bytecode, even if you try to load it with something which is called the DEX class loader, at runtime it fails. And why it fails, I have absolutely no idea, but there is one workaround for that. And the workaround is, if you ever want to create a class at runtime, it's okay, but you have to write it to a file, put that file in a jar, and load the jar. And it works. Success. But imagine, for each class that you're creating at runtime, write something to the file system, load it through a dedicated class loader. Whoa. So that works, but it's painfully slow. So that is not what I wanted to do for Groovy. What really I wanted to do is not try to run the most dynamic aspects of Groovy, like generating classes at runtime, but rather write an application in Groovy, convert it to the native format of Android, and run it. Nothing more. Okay. So, yes, the drawbacks were that obviously it was slow, but I must say that this way of loading the classes, etc., is actually what the Ruboto project does. Any of you is aware of that project? It's about running Ruby on Android. So you can do that, but well, it's only suitable, yes, for just proof of concepts. So if you want to see it in action, I actually have one application on my phone, which is a Groovy application that lets you write a Groovy script, evaluate it at runtime, and it works. But even with a phone like this one, which is a Galaxy Note 3, so quite a fast CPU, it takes a few seconds before you have the result. So, what did I do? Actually, I created a patch for the Groovy distribution. So it took some time to have that patch complete and keep it as small as possible. And actually, thanks to Alexander and Johan, to the discussion that we had, I managed to reduce it a lot. And you will see that in the end of this session. So you have a patch in Groovy. We can generate a new jar that we will use in a Groovy application. Oops. Come back, please. It's going crazy, sorry. Right. Okay. So now why my job was actually easier than the one from Marcin and Eric is that now Google provides by default a new IDE, which is Android Studio, based on IntelliJ, and this IDE uses Gradle underneath. So I have Gradle. Gradle at that time wasn't the build system from Android, so it was much more difficult. So I used that, and yes, I wanted to feel the pain. So I wrote the GrayConf agenda. Okay, I'm going to use the keyboard, because this is annoying. And this is the application. So you can download it. It works. Yes? That's you, yeah. I chose the best looking speaker. You know. So this application is working. You can download it on Google Play, and as far as I know, this is the first one written in Groovy actually, in Google Play. So to do that, there are several steps, and the first one was to manage to compile those Groovy classes that I have. Even before trying to make them run on Android, it was to compile them. And the problem is that the Android plugin for Gradle does a lot of special stuff on the Gradle build, and you cannot just use apply plugin Groovy, because apply plugin Groovy depends on the Java plugin, and the Java plugin is not compatible with the Android plugin. So the first step for me was to analyze that and try to compile. So I added a dependency just for my application. So the difference here is that now I have a single classifier. So you have a special Groovy core jar which is ready for Android. And in this one, I'm using the JSON parser module of Groovy just because the feed for the agenda is a JSON feed. So using the parser, and the transitive equals false is just because if you don't put that, then you get the normal Groovy jar in addition to the classifier. And this was the most complicated part in the Gradle build. It's just about introspecting what the Android plugin does, attached to those Java compilation tasks, and generate Groovy ones instead. So hopefully this will be part of a Groovy Android plugin for Gradle at some time, so you will not have to write that yourself. Just apply plugin Groovy Android and it will be okay. So don't focus on that, just to show you. And then once you do that, you can write an application in Groovy. So you had to use compile static everywhere. So I will explain why had, but since the beginning of this week, I had to. And for me, it wasn't really a problem, because in my thinking, if you write an application for a mobile device, you want to to be as snappy as possible, keep it as small as possible, and do you really need to have some dynamic aspects in a mobile application? Well, most likely no, but there are some places where it's interesting to have them just builders. If you wrote those ugly XML files to write the UI, you know that a builder would probably be nicer. So thanks to Johan, I managed to have those running without the compile static annotation a few hours ago. So really, I'm quite happy with that. So you can now run dynamic code on Android too. The only limitation is that you still cannot have classes generated at runtime. So basically, the limitation would be that some coercions that you use with the S keyword, typically that involve creating a class at runtime, will not work. Do you want to see it? Okay, let's do this. So this is Android Studio. Nothing very fancy. I forgot to mention that all the code is already available on GitHub. So if you want to take a look at this, you can open my GitHub account, and you have the GradeConf agenda project inside, and you can take a closer look at the code. So let's start with the beginning, which is the Gradle build. I don't know if the presentation mode works. Yes, it works in Android Studio too, so excellent. Right. So yes, this is the top level one. I always get bitten by this. You have two levels. When you create an Android project, I don't really know why, but you always have this nested structure, just as if every project was a multi-module project. I don't know why. Okay, so, oops. So I had to do some things like that to work around problems, actually not in Groovy, but in the Android plugin for Gradle. So that's a good sign if the problems you have are not Groovy problems, but problems from the others. But probably this is not what you want to see. You want to see if I can really run this application. And if I didn't lie, so it's named Java. Maybe it's written in Java. No. Okay, let's take a random class. So this one is the session detail activity. And whoa, it's written in Groovy. Yeah. So at least I can write code in Groovy. But does it compile? Yes, it does, of course. It does compile. But what you can see already is that this code looks pretty much like what you would have if you wrote an application in Java. It's just that you can use some Groovy-specific constructs. So my first problem was not to write something in Groovy, because obviously I know Groovy. My problem was to learn Android, and that's another good problem to have. Okay, so doing that, I learned the programming model of Android, and I saw that there are a lot of repetitive stuff, a lot of things that we as a community can fix. So my work was to get this compiling, and our work is to provide more grooviness to the Android world. So I hope that after this session you will do that. Okay, so I promised that I would show you that it works. So let's run the application. So what it will do is launch an emulator. So the good thing is that now the emulators are not that slow. They're pretty snappy. So, right. So this one is my phone, which is actually connected, so I can push my applications either directly to my phone or on a device. So I'm going to choose, say, the Galaxy Nexus, because the application is also compatible with tablets. If you have tablets, you can do it. So the device is starting. Once it's up, it's faster. Right. Oh shit, no battery. Okay, so the device is on, and now it's loading my application. And yes, it works. So it's pretty snappy. You can open everything. Colin, it's not there? So I must say that the first time I saw that, I was, whoa, I did it. And it was really awesome because I didn't expect it to be that fast. I mean, I don't notice any difference with the native Java application, which is a very good thing. So let's say that I want to debug this application, and this will prove that I don't have a fake Java application running. So I will take, for example, the session list activity and put a breakpoint here, which is a callback when you favorite a session. So I have to run the application again, this time with debug enabled. So you can see that actually the integration is a bit slow. You still have, even if you use Android Studio, it's using Gradle, and it always repackages the application. So even if you make no modification to the source code, you have at least a couple of seconds before you can actually run the device. But I guess you're aware of that. So let's choose the Galaxy Nexus. And I have to find the window. Here it is. Okay, so now if I go to the security workshop and click on that icon, I have the debugger working. So I am really in Groovy code. So you can debug Groovy applications written in Android application written in Groovy, but be aware that it's still not perfect. For some reason, I think the IDE is probably not aware that I'm using Groovy. So, for example, here in the watches, I can't use a Groovy expression. I think it thinks it's actually Java. So, probably tooling to be improved. Another problem is that I cannot create a new Groovy class. So I have to create a file, .groovy, and then it's okay, the idea works. So it's not that bad. It could be worse. Right, so let's continue and see. Normally, if I come back, oops, if I come back here, no, wait. Yes, so the callback fallback was just to set that. And this leads me to one of the problems I had writing this application. And when I said that Android development was so JDK 5, this is a typical example. There is no binding model, no binding framework in Android by default. So we made some searches and saw that there are some people providing binding frameworks for Android, but there are quite a few. I learned yesterday that Griffon 2 will be based on Gradle. So I hope that someone will write a plugin for Griffon to make this easier to write applications for Android, because otherwise, if you don't do that, you have to create so many inner classes just to react to the events and update the UI. It's just crazy how much code you have to write just to update a star. You send an event, the event comes back, you have to register a listener and register the listener, etc. Oh, so much boilerplate code that honestly I'm not used to when I use Groovy code. So it was really painful. So, cool guys. Okay, let's come back to the slides. One of the questions that you must have now is, how does it compare to a native Java application? How many people know the size of the Groovy core jar? Yes? More. It's more. It's around 4 megabytes. So 4 megabytes. And actually the Groovy for Android jar is a bit bigger than that, because Android doesn't bundle, for example, the java.beans package. So part of the patch to the Groovy distribution is to have OpenBeans from the Apache Harmony project packaged with the Groovy jar, replacing the java.beans package, because Groovy internally uses that. So it's a bit larger than that. So the Groovy jar for Android is 4.7 megabytes, almost 5 megabytes. That's not cool for a mobile application. But surprisingly, if you compile it, whoa, only 2 megabytes. The whole application consumes only 2 megabytes. So apparently the DEX format is kind of optimized, and that's quite cool for us, because it means that our application will consume only 2 megabytes. That's cool. But Android comes with a tool that you can activate, and that tool will analyze all your code and remove everything which is not necessary. And it's called Progwad. You have some rules to write, and if you do this, you can reduce the size to 1 megabyte. So that's nice, I think, for just an application, a simple application. Just reducing the size of the application to that is, I think, acceptable, even for a mobile application, because you don't always download a new version of the application. Maybe you can do more. You have to know that the rules, I can show them if I have, yeah, I have time to show that. You have to know that by default, this tool doesn't know anything about Groovy, so it removes a bit too much. So we had a problem yesterday that when I tried to make that dynamic aspect of Groovy running on Android, there was an error saying that my property didn't exist. Say, it's here, it's in the code, it exists. So we're trying to find a bug in OpenBeans, because normally properties are introspected using open beams, and actually the problem was ProgWAD, because it told that my field wasn't used, so it removed it. So yes, you have to be aware that you can have some surprises, so better develop your application without that tool and later optimize it, just seeing what crashes, and this is pretty much what I did actually. So just to show you what the file looks like. Oops, it's ProgWAD rules. Yep, and switch to the presentation mode. Right, so this is just a file where you can tell, okay, don't obfuscate. So this is important because even if you use compile static, there are some dynamic aspects that remain in the core of the language, and if you obfuscate the code, it doesn't work anymore. So probably you can obfuscate part of the code, but not all. And you can say rules like, okay, keep those classes because they're important for the Groovy runtime. So you have, yeah, you can say, okay, all the classes in that package, all the members of that class, etc., etc. So you have to do that, it works. It is blinking saying that I ran out of time. Is it normal? Or I thought I had 20 minutes more. Okay, thanks. That's no problem. Right, so come back to the slides. Only 1 megabyte, that's cool. What about RAM? Memory. Because often Groovy is known as consuming a lot of memory. So what I did is actually taking a snapshot of my application, and it told me, okay, it only uses 8 megabytes of RAM, so I can show you actually the result of that. So I'm using a profiler, just a profiler for that. And you will see one interesting thing. So let's open the snapshot. If it's this one. Yes. So actually what we can see, it's a bit small, but I don't think that I can improve the size. What we see is that we have a lot of finalizer reference. Just basically it's the garbage collector hasn't done any job yet. And if I do calculate the exact retain size of my application, we fall down to 2.5 megabytes of RAM. And most of the RAM is actually taken by the pictures I have in the application. So it's pretty cool. It means that it doesn't consume that much resources. Does it? I think it's okay. Now, this was my job. I felt the pain, and I started being more comfortable with the Android APIs. I was getting tired by all those APIs that require me to write anonymous inner classes. I probably think that Android is the anonymous inner class paradise. They seem to love that. You have to write inner classes everywhere. But in Groovy, we have closures. And in Android, you're still stuck to, I think it's, maybe you can use Java 7. I'm not even sure you can use Java 7. So before you can use Java 8 on Android, it will probably take a couple of years, maybe more. And we have closures, so let's use closures. And one of the examples that I have about that is the async task. So maybe some of you know what it is, but basically in Android you must run every long-running task like getting something from the network on a separate thread so that it doesn't block the UI. This is a best practice which is enforced actually by the Android framework. So you cannot run, for example, getting a feed, the JSON feed from the main UI thread. It's not possible to do that. So you have to run an async task. And it has several parameters. Okay, you can do in background, which is the actual work. So get the feed, and then you can do something when the result is available. And actually, this reminded me of APIs that we are used to use in 2014, like the Promise API, for example. So what if we could reduce that to async, just a single static call with a closure saying, do that asynchronously, whatever, you get the word. And when the result is available, update the UI. 2 lines of code instead of a full stack of inner classes. So this is your job, not mine. Please provide us, give us tons of those APIs that simplify development of Groovy applications. Now that Groovy runs on Android, you can do that. You can improve the situation and you can provide all the goodness of Groovy to Android. So this is just an example, but the other obvious example is builders. Instead of having code like those XML files, or yeah, it's not necessary to show you XML file. I think it's just before lunch. It would just cut your appetite. So what if you could use Griffon-like builders in Android? Wouldn't be cool for that? It would, but someone has to write it. Please, guys, do it. And you have to bring Groovy to the Android world, especially now that the Apple guys have Swift. We have to do something as a community. So the future, for me, my job now is more to streamline the distribution. What does it mean? It means that we have a patch to Groovy, and it has to be integrated somehow because you can build it from source today, but it's not very nice for you. But you can do it. If you want to use Groovy today to develop your application, it is possible. You just have to build my branch and you're done. You can have something in production. But I would make that easier. Of course, there's bug fixing because I found a lot of bugs actually in inner classes using compile static with and without compile static actually. So bug fixes, a lot of them are ready already. Nice word. And yes, this is for you. Goodness, API goodness, do it. For you, you have to improve the tooling. And of course, you have to tweet that you love using Groovy on Android. So I wanted to do something with you, which is actually the first one, and ask you a question. So first, I need to show you the modifications that were made to Groovy to have this working. So let's open the GitHub project. And actually, I have a pull request, which is to make Android run, Groovy run on Android. So you can take a look at that code, or you can trust me and Johan and Guillaume. And the question for you now is, do you want me to press the pull request button, merge it, or no? If you didn't like that session, I won't press the button, and my life will be easier because I will not have to maintain that. But I think it's cool, so raise your hand if you want me to press that button. Oh, I'm not sure. Let's count. Okay, so let's do it. Merged. Thank you. Sorry? What was the... No? Nothing I have to learn? So of course the pull request was tested by our CI server before, so it doesn't break anything existing. And now I cannot rebase anymore. So my life will become more complicated thanks to you guys. So it's time for questions. Yes. No, I don't think it is. No, really. Yeah. So the reason I didn't talk about that, but maybe you're not aware of how the Gradle plugin works for Android, but the reason why it's not using the bundle Java plugin is that you have all those application variants. So for example, in Android, you will want to write an application that runs on some devices using some specific CPU, so ARM or Intel, etc. So those are variants. But you will also have variants for example, debugging, variants for paid version versus a demo version. So the plugin takes care of generating all the combination for all those variants. So you will have the paid version for ARM, the paid version for Intel, etc., etc. So this is why I have to do those tricks on the Gradle build to have this running actually. Another question? So how many people now would like to try it? Good, very good. So I have a few minutes, so maybe I can show you now. Modifying the code is not that hard. So this application is on GitHub, so you can open it. Just show you the URL so that those who don't have access to Wi-Fi can remember that by heart. So you can open this application, fork it, and if you want to do pull requests, I know that the GradeConf US conference is probably using the same backend as I understood. So this application misses some features. Some guys have found bugs. So it's open source, you can contribute to it, and it would be a good start because obviously everything is ready for you. Okay, so if there are no more questions, then enjoy your meal. Thank you.